everyone, this is Suprava. Welcome back to another session with me. In today's session, we will be discussing about the circulation, baby circulation just right after the birth. So in the last session, we have discussed about the fetal circulation, that is when the baby is in the uterus. How does the circulation takes place? So we have discussed about that in the last session. So I hope you have gone through the last video. This is the first part of this topic. Now here we are going to discuss about once the baby is born, how the circulation is going to take place. Now we know that there were certain adaptations or shunts which were present in the fetus. So when the baby was in the uterus, that time there were some shunts present, right? And that was helping in the circulation. And those shunts plays a major role once the baby is delivered. Well, once the baby is delivered, there would be certain, changes that would be happening in the first few days of life. So, can you think of some major changes that happens just, after the birth? So, the first change is that the placenta would be removed. So, we are going to cut the umbilical cord. And then we also know that the placenta was providing oxygen-rich blood to the fetus, and now we are going to, once the baby is delivered, we are going to cut that off. So that means from the baby's circulation, placenta is removed. So now there is no placenta around in the baby's circulation. The second thing that is there is the lung starts working, right? So we know that, the baby would start crying. Right? So once the baby starts crying, what happens? The fluid present inside the lungs is going to, come out, and the lungs are going to get filled with air. So that's going to start functioning. So that is the second change that happens. So here, one thing to notice is that the main source from where the baby was, getting oxygen-rich blood and nutrients, that has been removed. And again, one more thing is the lungs which were not functional has started functioning. So that means if the lungs are functioning, that means there is a need for the blood to go to the lungs to get it oxygenated, right? Because the lungs are now present to oxygenate the blood. So these two major changes are happening. And when these two major changes are happening, that can affect, a whole lot of other things as well. Well, now these two changes will affect the circulation in a way. So let us see one by one. So first, let us concentrate on the placenta. So what happens when we remove the placenta? What happens to the circulation? Now, to understand that, we need to know a bit more about the placenta. So, let us see what is there in the umbilical cord. So, there is a substance which is present. It is a gelatinous substance which is present in the umbilical cord. And this substance is called as Wharton's jelly. Well, now you might be thinking that why we are talking about Wharton's jelly? What is the importance? What it does? So this plays a major role in, in providing cushion or, in protecting and providing support to the umbilical vessels. So this prevents torsion of the vessels, because we know we have three umbilical vessels, right? That is one umbilical vein and two umbilical arteries. So there is a chance that these vessels can get, bended. These vessels can get, there might be torsion. So what this jelly does, this jelly keeps it intact, and this prevents this, torsion of these vessels. So basically, this jelly is keeping these three vessels intact, and it is preventing compression of these vessels. But we also have to remember that these things are happening inside the mother's body. So that means this jelly is working in this manner when it is inside the mother's body. And there is one more thing which we have to notice is that there is a temperature variation. There is a difference in temperature inside the mother's womb and outside the mother's body, right? So what happens when once the baby is delivered, we are going to clamp the umbilical cord, and this jelly starts to contract. This jelly starts to contract as soon as the temperature falls. So it starts to get tighter around these three vessels. So basically this jelly works under a specific temperature, because the temperature inside the mother is much warmer than of the delivery room. So what happens once a baby is delivered, we are going to clamp the umbilical cord, and because of this temperature variation, this jelly starts to contract, and because of this contraction, what happens, it starts to get tighter around these three vessels, and eventually is going to squeeze down all these three vessels. So now no amount of blood can flow through these vessels. Let us remember what was happening when the placenta was there. So when the placenta was there, what was happening? A lot of amount of blood was coming to the placenta, and again it was going going out of the placenta. So there was no resistance. So there was really low resistance. But now this is becoming high resistance, because all these three vessels are constricted, and that amount of blood which was coming to the placenta through these three vessels would not be able to come now. So what is happening? This low resistance placenta is becoming high resistance. So now here we have high resistance. So what happens? All that blood which is coming, it starts to clot, and in the first few days of life there is no blood flowing through these vessels, and the same thing happens to the ductus arteriosus. Now, if no amount of blood is flowing through these vessels, then it becomes, it doesn't get used. So if there is no blood flow, it becomes non-used over the first few days of life. And what happens, we also have to here we have to notice that we have already cut down the placenta, right? So there is the baby's circulation does not have any connection with the placenta, and these three vessels initially one of these vessels were carrying oxygenated blood from the placenta, but now as there is no connection with the placenta, all of these vessels are carrying deoxygenated blood. So what happens? This deoxygenated blood flows towards the inferior vena cava, and some of the blood would also enter the hepatic portal vein. Now, the blood which enters the inferior vena cava would eventually reach the right atrium. So, what is happening here? The deoxygenated blood from the head and neck, the upper extremities, would come to the right atrium through the superior vena cava, and the deoxygenated blood from the lower limbs would go to the right atrium through the inferior vena cava. So that's how all this deoxygenated blood is reaching the right atrium. So now we have all this deoxygenated blood in the right atrium. So from the right atrium, the blood is going to come to the right ventricle through the tricuspid valve, and from there it's going to go to the pulmonary artery. Right now, from the pulmonary artery, it's definitely going to go to the lungs, because we know the lungs has started working. So as soon as the baby is delivered, the baby starts to cry. It starts to breathe on his own. So all that air the lungs are taking, it's going to push the fluid out of the lungs. And the alveoli which were filled with fluid is going to take air in it. So what would happen? There would be increased oxygen level in the lungs. So what would happen? There would be increased oxygen level in the alveoli. And when there is increased oxygen level in the alveoli, the next thing that would happen, there would be, the resistance in the lungs would fall down. Now, if the resistance in the lungs is falling down, then definitely the resistance in the pulmonary artery is also going to fall down. Because previously what happened, the lungs were filled with fluid. right? So there was so much resistance in the pulmonary artery, because it was, it had to act against so much resistance, because it was not able to pump the blood to the lungs. But now the resistance in the lungs has fallen down, so definitely the resistance in the pulmonary artery is also going to fall down, so it's easier for the blood to get into the lungs. So when we are saying that, the resistance in the pulmonary artery is falling down and it's easier for the blood to get into the lungs, that means also that the pressure on the right ventricle is also, falling down, because the right ventricle has to pump the blood through the pulmonary artery to the lungs, right? So initially, previously what happened, as there was increased resistance, the right ventricle also had to pump harder to push the blood to the pulmonary artery, right? Because there was so much resistance in the pulmonary artery. So now the resistance has fallen down. So that means the pressure on the right ventricle would also going to fall down. So if the pressure on the right ventricle is falling down, that means the pressure on the right atrium would also fall down. So the entire right side of the heart is having decreased pressure now. And that's because the resistance in the lungs has gone down. And that also means that more amount of blood is getting into the lungs. And if there is more amount of blood going into the lungs, there would be, the oxygenation is also occurring more, right? So this oxygenated blood comes to the left atrium from the lungs. Well, now here we have to we have one more structure which is there, the shunt, that is foramen ovale, right? And also here we can see that there is a pressure change, right? So the right side of the heart had higher pressure, but now the pressure has fallen down. So the right side of the heart has lower pressure, and the left side of the heart has higher pressure, because it is receiving increased amount of oxygenated blood. So what's going to happen? The foramen ovale is going to close off. Okay, because of this pressure difference, the foramen ovale is going to close off because it's not needed anymore. So how it's happening? As the pressure on the left side is higher, that pressure would push the flap of tissue which is there, and the foramen ovale. So the pressure would push that flap of tissue over. So that's going to close the foramen ovale. And so basically now our this shunt that was present in the fetal circulation, that is foramen ovale, is closed now. And this happens during the first few minutes of life. So here we have one more structure, that is ductus arteriosus, which connects our pulmonary artery to the aorta. And now let us remember how this ductus arteriosus used to work when it was, in the fetal circulation. So when the baby was inside the mother's uterus, how this ductus arteriosus used to work. So basically at that time, what was happening, we had higher pressure on the right side of the heart and lower pressure on the left side of the heart. So what was happening, this the blood was it was being shunting from the pulmonary artery to the aorta through this ductus arteriosus, because the pressure on the right side was higher. So the right ventricle was pushing the blood with so much pressure through the pulmonary artery, and that's how it was getting shunted to the aorta, right? But now after birth, the pressure has changed, right? So what has happened? Now we have higher pressure on the left side and lower pressure on the right side, right? Now this left side of the heart pushes the blood to the aorta, right? So what would happen, this ductus arteriosus, the blood which is going through this aorta would drop down to the pulmonary artery from the ductus arteriosus. So the blood will be shunted from the aorta to the pulmonary artery, right? So that's how it should work. But interestingly, this is how it's not going to take place. So that means the blood would not come from the aorta to the pulmonary artery. So there would be some changes. Now, what kind of changes? So there would be constriction of the muscles of this ductus arteriosus in the first few hours. Now, you might be thinking how this ductus arteriosus would close. So there are two things which would make the ductus arteriosus close. The first thing is that the muscles of the ductus arteriosus would sense that there is increased oxygen level, right? Because the lungs has started working and the alveoli started taking air. So there is increased amount of oxygenation. And there is increased amount of oxygenated blood is going through these vessels, right? So ductus arteriosus is going to sense that, and that would help in constriction of the muscles of ductus arteriosus. And also the ductus arteriosus is going to sense that the placenta has been removed. How? Because we know that the placenta used to secrete prostaglandin E. Now, when we have cut down this placenta, the prostaglandin E is not there. So there is decreased amount of prostaglandin E. So that would, helps the ductus arteriosus to close. Now, what's going to happen to the umbilical arteries? Now, the internal iliac arteries have branches, right? And we know that it has, branches to the umbilical artery. So to the umbilical part. So this part is also going to sense that there is increased oxygen and decreased level of prostaglandin E. So that's also going to, these vessels also would start, getting constricted, and eventually it would close down. So that is how these umbilical arteries would also close down. Well, these are the changes that occurs just right after the birth, and this is how the circulation occurs. So I hope you have got a better insight about the topic. Thank you.